All right, this is the last video that you have to watch for the Chapter 11 unit on gas laws. This last video is going to teach you how to do stoichiometry problems where your conditions are different than STP, standard temperature and pressure. Now, if you think back to when we learned how to do stoichiometry, we always used we always used 22.4 liters when we were converting from moles. That was a number we memorized, 22.4. The problem is 22.4 only works for us when it's at STP. What do we do when it's not at STP? Well, we don't panic. We just use stoichiometry first, and then we're going to use what we've already learned in the ideal gas law. So we're going to work through an example. That's probably the simplest way to do this. Now, it might require you to go back and watch a mass volume video just to remind you how to do some stoichiometry if you were struggling with stoichiometry back in chapter 9. Um, However, if you feel comfortable with stoichiometry, you might want to just continue on right now. The example problem is going to look very much like practice problems we did back in chapter 9. This one example says, calculate the volume of hydrogen produced at 0.75 atmospheres and 28.5 degrees Celsius by reacting 30 grams of magnesium with excess hydrochloric acid. So in any stoichiometry problem, you might remember that the first step is always to write a balanced equation. So we want you to write a balanced chemical equation. Now, if you really want to test yourself, what I'd do is pause the video right now and see if you can write a correct equation for magnesium reacting with hydrochloric acid without my help. And then when you're ready, check your answer by pushing play. If you're going to just kind of want to try it on your own, push pause now. Otherwise, we're going to take magnesium, which is Mg, and we're going to react it with hydrochloric acid, which is HCl. This is going to be a single displacement reaction. The magnesium is going to push the hydrogen out. We're going to get MgCl2 as a product and hydrogen gas. Now, the reason that it's MgCl2 is Mg has a +2 charge, Cl has a -1 charge. So if you crisscross, you have to have MgCl2. The reason the H has a 2 is it's one of our 7 diatomic elements that we had to memorize. Now, we've written the equation, but right now it's not balanced. If you look, you'd need to put a 2 in front of the HCl to balance the equation. Now, we're going to start this very much like we did stoichiometry problems in the past. We're going to put our givens and our unknowns. Now, our given that we're starting with is 30 grams of magnesium. So under the magnesium, I'm going to write 30.0 G for grams. And I'm wanting to find how many or what the volume of hydrogen is. So my question mark is going to go under hydrogen, and volume is always measured in liters. Could be measured in milliliters or decimeter cubed or centimeters cubed. Now back in the stoichiometry unit, we learned that we were going to take our grams, and I even had that goofy puppet that some of you really thought was cheesy, and we remember we dig holes down. So grams get converted to moles, and then moles get converted to moles. And our last step was always to go back up to liters. But I'm going to tell you right now, stop. Don't go up to liters because we cannot use 22.4. This is illegal. If we were to do this, if we were to try to do this using 22.4, we'd get the wrong answer. So we're not going to do it. We're going to stop at moles. So the next thing that I want you to do is to use, let me move these things out of the way. Use the math that you've already set up. So we're going to follow the blue path. We're going to take 30 grams of magnesium, and we're going to convert that to moles. Now, for some of you, putting this over 1 is really helpful. So on the bottom of this label, we want grams of magnesium. On the top, we want to turn it into moles of magnesium. Now, you remember that 1 mole, and you look at your periodic table, has 24.31 grams. Next step, once we have moles of magnesium, is to convert the moles of magnesium to moles of H2. So I want to get rid of moles of Mg. I'll put that on the bottom. I want to turn that into moles of H2. I'll put that on the top. Now, in your mole-mole step, you'll remember that this comes from the coefficients. The coefficient in front of H2 is an understood 1, and so is the coefficient in front of magnesium. Now that's where you're going to stop your math. If you look, what you've done is you've taken the grams of magnesium, gotten rid of them, by turning them into moles, and then gotten rid of the moles of magnesium by turning them into moles of H2. So if you do that math with your calculator, why don't you try that now? You should get 1.23 moles of H2. The problem is we're not done. The problem asked us to solve for volume of hydrogen, and what we have is moles of hydrogen. So what we're looking for is to convert those moles to a volume. So we stop there, and if you notice what we said in the problem, the directions, we're going to use stoichiometry first, and now we're going to use PV equals nRT. So second step, actually, we can say this is just use PV equals nRT. Now we're going to rearrange to solve for V. So V equals nRT divided by P. Now what you just solved for was N. N was 1.23 moles of H2. Going back to the original problem, we were given a pressure and a temperature. The pressure was given as 0.75 atmospheres. So on the bottom, I'm going to put 0.75 atmospheres. The temperature was given as 28.5 degrees Celsius, which is the same as 301.5 Kelvin. Remember, when we use ideal gas law, we have to use kelvins. Now, the only thing that's missing is our R value. Since the pressure was given in atmospheres, I'm going to use an R value that's in atmospheres. So I'm going to choose to use 0.0821 atmosphere liter over mole K. Now, a lot of you are going to crunch numbers in your calculator, which is just fine to do. And when you get your calculator answer, you should get 40.6 liters. And if you look at your labels, this is where they cancel out. Moles of H2 will cancel here with that. ATMs are going to cancel, and Ks are going to cancel, so our label has to be liters. So our answer is that at these unique pressure and temperature conditions, we'd get 40.6 liters. Now there's a practice problem for you to try right here that you should try on your own. This is actually, try this on your paper, and then this is going to be your learning check that follows this video. Good luck.